Question 6, at last we've come to a circuits question. 4 identical new cells, each of EMF 1.5 volts, and the good news is they've all got negligible internal resistance. The resistance of each resistor is 4 ohms, the total resistance of the circuit. You probably can do it in your head. If it was more complicated numbers, then you'd be able to work out the parallel resistors first, and then sort of say whatever that comes to as a parallel pair, it's in series with another resistor. As I say, it's also easy, you should be able to get the answer in your head. Calculate the total EMF of the combination of cells. So it's easy coping with cells that are in series. Should know what you do with the voltage then. When cells are in parallel, what do we do with those? It is really easy. If the EMF across cell A is 1.5 volts, and the EMF across cell B is 1.5 volts, then the EMF between there and there is 1.5 volts. So we don't add up the voltages. The voltage across the two together is the same as the voltage across each of them. So we know what the voltage there is, and we've got 2 more in series, you can find the total. Calculate the current passing through cell A. Well, we've worked out the total resistance for the whole circuit, and we know the total EMF for the whole circuit. So we can use the equation I equals V over R, because in each case the V's for the whole circuit and the R's for the whole circuit, so they belong together. So it is a straightforward case of using I equals V over R to find the current for the whole circuit. But the question is the current passing through cell A. Now think about the current in the circuit. It splits there, joins back together. It splits there, joins back together. So the current through cell A will be half the current that would say was the current for the whole circuit. The charge through cell A in 5 minutes. Well, if you know the current, and you know the simple formula that links current and charge, and you remember not to make a silly mistake, you just say 5 minutes and not 5 seconds, it should be easy to work out the charge. The last bit, each of the cells can provide the same amount of energy before going flat. State and explain which 2 cells you would expect to go flat first. Well, it says they all provide the same energy, and they're all the same voltage. The voltage means how much energy they give to each coulomb. So all 4 cells give the same amount of energy to each coulomb. So which ones will run out of energy first? The ones that have the most coulombs passing through them. And of course the ones with the bigger current will have the most coulombs going through every second, so they'll run out of energy first. So you need to think which cells have got the biggest current flowing through them.